In this video, I'll be discussing how the intervertebral disc takes up the compressive load on the spine. So first, let's understand the structure of the intervertebral disc. These are the vertebrae. This is the disc. Now the disc is made up of nucleus pulposus, annulus fibrosus. This is the nucleus pulposus. This is the annulus fibrosus, and there is cartilaginous end plate. Nucleus pulposus is the round incompressible fluid-like structure in between, and the annulus fibrosus, this structure is made up of concentric structures surrounding the nucleus pulposus. Now, the nucleus pulposus is an incompressible structure. By incompressible, it means that the nucleus pulposus cannot be compressed. So whenever there is compression on the spine, whenever the spine is loaded, this nucleus pulposus will not get compressed. So what will happen? There will not be any change in the volume. What will change is the pressure. Let's understand how. So first let's understand how the structure of nucleus pulposus is when the spine is unloaded. So this is in the unloaded state. The nucleus pulposus is circular. Now when the spine is loaded, this nucleus pulposus is going to deform. It is going to expand in shape. It is going to deform. Now because it is incompressible, it will not get squeezed. It will change in shape and there will not be any change in the volume. What will change is the pressure. So whenever the spine is loaded, there is pressure on the disc. The nucleus pulposus is going to expand like this and it is going to exert pressure equally in all the directions. So this is the annulus fibrosus, on which the pressure is exerted by the nucleus pulposus. Now what does the annulus do? The annulus exerts a force that is equal in magnitude but opposite in direction to that of the force generated by the nucleus pulposus. This will help in resisting the compressive forces, and that is how the load is taken up by the spine. Now this annulus fibrosus, so this is the nucleus pulposus, this is the annulus fibrosus. So when pressure is exerted like this, the annulus fibrosus exerts pressure in the opposite direction. Now why does this happen? Annulus fibrosus is made up of collagen, and collagen type 1 collagen, and function of type 1 collagen is to exert tensile strength. And what are tensile forces? Forces that are opposite in direction. So here, this is the force exerted by the nucleus pulposus, and the annulus exerts force in the opposite direction. So tensile strength is being provided by the annulus fibrosus. So this is what happens in a normal disc. This is what happens with a normal disc. Now when the disc degenerates, what is going to happen? Now the nucleus pulposus is not that incompressible. Why was the nucleus pulposus able to take up all this force? Because of its fluid content, because of its hydrophilic property. Now because the disc has degenerated, the fluid content has decreased, the nucleus pulposus will not deform when there is compression. Whenever the spine is loaded, now this nucleus pulposus is not going to deform and change in shape. All the load will have to be borne by the annulus fibrosus. Now annulus fibrosus is not used to taking up direct compressive forces. Annulus fibrosus was used to taking up the pressure that was exerted by the nucleus pulposus. But now what is happening? The pressure is not exerted equally in all the directions. Earlier the pressure was exerted equally in all the directions. Now because the disc has degenerated, there is going to be uneven pressure distribution. Some parts will have to bear more pressure, some will have overall the disc will have an uneven pressure distribution, because of which now, and also the annulus fibrosus takes up more, the annulus fibrosus will have to take up more stress which it is not used to, which will lead to a break or a tear in the fibers of the annulus, and through which this nucleus pulposus is going to migrate out, and that is what is known as disc bulge. So this is the nucleus pulposus, this is the annulus fibrosus. Now the annulus fibrosus is subjected to excessive stress which it is not used to taking up. So there will be a tear in the fibers of the annulus fibrosus, and this nucleus pulposus will then come out of this and into the spinal canal, depending upon the stage of the depending upon the stage of the herniation. So that is how disc bulge occurs.